Okay, the next few problems are challenging in that they are definitely a mess. We're taking the tangent equation. We're applying every transformation there is. So there's a vertical stretch, there's a horizontal stretch or shrink, there's a horizontal shift, there's a vertical shift, looks like there's a reflection. And we're doing it with decimal radians instead of exact value radians. So this is probably different than anything you did last year. It's similar to what you did last year, and that is just equation solving, and it's equation solving in a challenging way. So we're going to go through how to do this so you guys can get some practice with it this summer. So we need to get the tangent of the parentheses by itself, obviously. That's when we solve. So we're going to start by doing that. So I have negative 0.692 after adding the 4 equals negative 1/5 tangent parentheses negative 3 theta plus 3 pi over 4. Okay, then I want to multiply both sides by negative 5. And use my calculator. So negative 5 times negative 0.692, or 5 times 0.692. This would be 3.46. So 3.46 equals tangent of negative 3 theta plus 3 pi over 4. I want to take the inverse tangent of both sides to get the negative 3 theta plus 3 pi over 4 by itself. Because there's a scalar multiple in front of theta, okay, there's a b, tangent b theta. That means the period is different. Instead of the period being pi, the period is going to be pi divided by 3, which also means that there's going to be 3 times as many solutions from 0 to 2 pi. So we're going to take the inverse tangent on both sides, see what happens. On the right-hand side, we're going to be left with negative 3 theta plus 3 pi over 4 that we can manipulate once we get our general equation. So I need to take the inverse tangent of 3.46. So second tangent, 3.46. And it tells me 1.289. And we'll use the calculator's exact value here. We'll just round it when we say it verbally, 1.289. That means if I take the tangent of 1.289 radians, I will get 3.46, right? So tangent of 1.289 radians is approximately going to equal the number 3.46. So we're just working radians instead of degrees. So let's take a look at our normal graph and look at our quadrantal values. So we know 0 radians and pi radians, but for pi now we're going to do 3.14. We can also do pi divided by 2, see what number that is. So pi divided by 2, a 90-degree angle is going to be 1.57. And then also 3 pi over 2. And that's at 4.71. So our calculator said the inverse tangent of 3.46 was 1.289. Okay, that's the radian measure that we were dealing with, 1.289. So if we look at the decimals here, we can see that 1.289 is going to be a quadrant 1 angle. Okay, we know that tangent is positive in quadrant 1. We also know tangent is positive in quadrant 3. So I need to find the reference angle there. Or I know the reference angle, it's a 1.29, 1.289 reference angle. But I need to find this entire angle. The entire angle is going to be 1.289 plus pi. Okay, or I can even use that as my, I don't need those two specific angles. I can actually use that as my, my general solution. So up here, instead of saying 1.289, I'm going to say 1.289 plus pi n. So that's my general solution. That'll give me every value for tangent that's going to be equal to 3.46. So I'm going to rearrange this equation so my theta's on the left because that's how I like it. So I have negative 3 theta plus 3 pi over 4 is equal to 1.289. I'm going to use my exact value in the calculator, but just writing it down. 1.289 plus pi n. And I need to get theta by itself. So I'm going to subtract 3 pi over 4. And so I have negative 3 theta equals, and I'm going to actually do the subtraction since I have my calculator going. So I'm going to do that 1.289 value that's on my calculator minus 3 pi over 4. So you can scroll up and find it, or you can type in that inverse tangent again. So 1.289445571 minus 3 pi over 4. Wrong button. It is negative 1.0667. I'm going to say negative 1.07. Plus pi n. Again, just rounding on my paper, but keeping the exact value in the calculator. I then need to divide by negative 3. So the second part just becomes minus pi over 3n. And the first part, if I divide that by negative 3, I get 0.35558, so 0.36. Okay, so there we have it. We have theta equals 0.36 radians minus pi over 3n radians. So I can let n equal 0. That'll give me an answer between 0 and 2 pi. If I let n equal 1, that's going to give me a negative number because I have 0.36 minus pi over 3n. So we're going to do 0, negative 1, and let's see how many do we need to do. Do we do n equals 0, negative 1, negative 2, negative 3? What's going on? We knew normally that we're going to hit this 1.289 radians twice on the unit circle, but with the times 3, we should have a total of 6 answers. So n is going to be from 0 to negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. So I have this 0.36 number, and I just need to add, essentially, pi over 3 to get my answers. So on my calculator, I have this number. That's for n equals 0, and then plus pi over 3. So now I have 2 answers, 3 answers, 4 answers. That's going to start to go off the screen. Let's see if I can capture that. Enter 2 more times. 5 answers and 6 answers. Okay, so we have those 4 and these last 2. And notice my last one stops before 6.28 or 2 pi. If I would have hit enter one more time, I get 6.6. It's outside of that domain of 0 to 2 pi. All right, I'm going to stop there. This video is long enough. Feel free to watch it again or go through the other problems too.